Today we're going to be looking at Unit 8, Day 3, where we're going to be working more with rational functions. This time we're going to be looking at rational expressions versus looking at the graphs of the functions. So if we take a look at something similar to the idea for our rational expression, we know a rational expression is just fractions, right? A numerator and denominator are being compared. And we always like to write our expressions in the most simplified format. So when we have had problems like this in the past, we've always asked ourselves, what factors make up the values, and are there any common factors that we could divide out from both the numerator and the denominator? And we're going to do the same thing here. So let's think about factors for 6 and 10, 7 and 28, 32 and 24. And we'll write out the factors so we can see what we're working with. Well, we know 6 comes from 2 times 3 and 1 times 6. And 10 comes from 2 times 5 or 1 times 10. Thinking about what they have in common, they both had a 2, so we can use that to write our factors for our numbers. Same idea for 7 and 28. We know 7 comes from 1 and 7. 28 comes from 7 and 4, so if they have something in common, we could use that. 32 and 24, we can think about their factors, and we know that they have 8s in common, so we could write our values using the 8s. So again, we're talking about looking at the factors of where the values came from, hoping that they have something in common we could divide out. So in our first problem, we could divide out the 2's, so we'd be left with 3/5. Our second problem, we could divide out the 7's, so we'd be left with -1/4. In our third, we could divide out the 8's, and we'd be left with 4/3. So we can also do the same idea with our functions, whether they're constants or whether they have some variables as well. So here we've got 2 more rational expressions. And again, we want to think about, for these coefficients, the same idea. What are their factors? Where do they come from? We're going to do the same idea with the variables. So we think about this one, 5x to the 8th and 15x to the 6th. Well, 5 we know comes from 1 times 5. And x to the 8th means we have 8 x's being multiplied together. 15, we could use a 3 and a 5 for its factors, and x to the 6 means we have 6 x's being multiplied together. And again, we're looking to see what they have in common that we could divide out. We could definitely divide out the 5. And then we look and say, well, they have x's in common. How many can we divide out? Well, we know x divided by x is 1. We could divide out a pair here, and here, and here, and here, and here. So a total of 6 pairs of x's could be divided out. And you want to see what you have left. We have 2 x's in the numerator, which would be x squared, and 3 in the denominator. So here's our simplified rational expression, x squared over 3. Let's try the same idea with this expression. We have -30x to the 5th divided by 18x to the 9th. So again, think about common factors they may have in common, and then what multiplies to 30 and 18. Well, we know that they have a 6 in common, so 30 comes from 6 times 5, and x to the 5th means we have 5 x's being multiplied together. 18 we know comes from 6 times 3, and x to the 9th means we have 9 x's being multiplied together. Well, things that we could divide out that's in common. We could divide out the 6's, and then we could divide out 5 pairs of x's. Well, what does that leave us with? -5 over 3 x to the 4th. So these are some very familiar types of rational expressions that we worked on simplifying in the past. We're going to use those same skills to continue as we go forward looking at some other rational functions. So let's try these here. Here we have r divided by 2r. Again, we want to put it in its most simplest term. By looking at our problem, again, you want to say, well, what do they have in common? They both have an r's that we could divide out, so we're left with 1 over 2. That's the simplified rational expression. Now we're going to look at b. We've got 5x divided by 5x plus 10. So think about the factors. Here we've got 5 times x for our 5x. And here, think about factors. Well, do these have anything in common that we could divide out? To truly think about the factors of where 5x plus 10 comes from. They both have a 5, so we could rewrite the denominator as 5 times the quantity x plus 2. And then again, we're looking to see what can we divide out from both the numerator and the denominator. Well, they both have a 5 as a factor, so we could divide that out. And what we're left with is x divided by x plus 2. Now remember, this is just the value of x, and here's a value of x plus 2. In order to divide things out, they have to look exactly the same in order to be considered a match. This does not have the plus 2, therefore they are not exact matches, and we have to leave our result as x over x plus 2 for our simplified rational expression. Let's try another scenario. Here we have 6m to the third minus 12m squared divided by 18m squared. Again, we want to look at the factors of the numerator and the denominator. So if I'm just looking at this polynomial here, and we're talking about the factors, I want to say, well, do they have any greatest common factors we could divide out from both of those to help simplify that polynomial in the numerator? And I can see they both have a 6 in common, and they have m. In fact, I could divide out 2 m's from each of those for an m squared. And look at the factored form. So I have 6m squared times m minus 2, right? This is maintaining the same value it was before. And that's divided by 18m squared. So we can think about, well, where does that 18 come from? 18 comes from a 3 and a 6. So it looks like we have some common factors that we could divide out going forward. Now numerically, we talked about dividing on a 6. Also, look at the variables. Here you have m squared in the numerator. You also have an m squared in the denominator. Those are a common factor as well that we could divide out. So if we divide out the 6, like we talked about, and the m squared, we're going to be left with m minus 2 over 3 for our rational function. Expression, I should say. Well, let's take a look at b. Here we have y divided by 7 minus y. Again, ask yourself, do we have all the factors for our pieces? So y only comes from 1 times y. There's nothing else we could do with that. And then 7 minus y, there aren't any greatest common factors, really, that we could divide out from that one. So if these are our factors, is there anything in common that we can divide out? Well, the answer is no, because this is y, and this has a value of 7 minus y. They are not exact matches to divide out. Therefore, this function, or sorry, this expression is already in its most simplified form. Let's try a few more. Here we have a rational function, x squared minus 3x minus 10, divided by x squared plus 6x plus 8. Now, in the past, we've looked individually at each of these polynomials to see if we could break them down into their factored form. And we're going to try that again here. So if we focus on x squared minus 3x minus 10, we want to see is there a greatest common factor other than 1 we could divide out from all those terms, and there's not. So the next thing we want to think about, are there two numbers we can multiply together to get negative 10, because remember, the leading coefficient times the constant, and add to get our middle term here of negative 3. If there is, we could use a 5 and a 2, in fact make that a negative 5 and a positive 2, and that will help us meet both of those requirements. We could look at the denominator the same way and say, well, x squared plus 6x plus 8, could I factor this? There's no greatest common factor other than 1, so again, leading coefficient times the constant. What times what gives you 8? What plus what gives you 6? I could use a 4 and a 2 there. So our factored forms, if we're looking at it, the numerator, we said x minus 5 times x plus 2, denominator x plus 4 times x plus 2. Now that we have the basic factors, like we've done in the previous problems, we should see if they have any common factors that we could divide out, any exact matches. Well, they both have an x plus 2, so we could divide those out, which means we're left with our rational expression of x minus 5 divided by x plus 4. Let's see if we can simplify this expression. Here we have x squared minus 7x plus 12 divided by x squared minus 16. Again, look for greatest common factors to divide out in each polynomial. Both of these polynomials do not have greatest common factors, so we can leave them as is. Same thing about your patterns for the numerator. Leading coefficient times the constant. What times what gives you 12? and what plus what gives you negative 7. We could use a negative 3 and a negative 4 to meet both of those requirements. So our factors would be x minus 4 times x minus 3. Our denominator, leading coefficient times your constant, what times what gives you negative 16, and what plus what gives you 0. Well, we could use a positive 4 and a negative 4. So here's our factored form. By looking at the factors, we want to see, is there a greatest common factor that we can divide out from both the numerator and the denominator? Again, they have to be exact matches. Well, we could see they both have an x minus 4, so if I divide that out, we'd be left with x minus 3 over x plus 4. So our simplified rational function would be just that, x minus 3 divided by x plus 4. Let's see what we can do with this. Here we have a rational expression. 2 times the quantity x minus 5 divided by the quantity of x minus 5 times x plus 2. We have a student's work. And what we want to do is be able to describe and correct the error in simplifying the irrational expression. Based on our original problem, can you determine which line the error is in and explain what the error is? So again, everything's in factored form. We're looking for common factors to divide out, exact matches. I see I have an x minus 5 in the numerator and an x minus 5 in the denominator, therefore I can divide those out, and we're left with 2 divided by x plus 2. So again, we're looking for things that they have in common to divide out. In line 3, the student decided to divide out the 2's. We can't do that, unfortunately, because they are not exact matches. They're not like terms. This is just the value of 2. This is the value of x plus 2. Therefore, we should have stopped the problem here at line 2 and said our most simplified result should be 2 divided by x plus 2. Again, only common factors, exact matches, can be divided out as we're simplifying our rational expressions. Now it's your turn to do more practice. If you could, look at your Unit 8 Day 3 worksheet. You have 9 rational expressions that you need to simplify by removing all the common factors. So again, look at the numerators, look at the denominators, break them down into their common factors, or break them down to their factors, then see what's in common that you could divide out. Always write them in the most simplified form as possible.